Okay, guys, so we're going to have a look at example 2 here, right? So we're going to need some of the skills that we dealt with this morning with the dealing with radicals, right? And rationalization, right? But what's nice is what I alluded to in the first part of this this lesson is they've told us a specific x value that they're interested in, okay? So what I like to do as I was figuring out these questions was to make that made my life easier trying to do this stuff. We can use this point to simplify our derivative from the standpoint of the overall math and cleanliness, right? Look at those less variables, right? And so the one thing I try to do is I write out the first principles law, right, which states that the limit as h approaches 0 of f at x plus h minus f of x divided by h, right? So it's very clear here. If you try to do it this way, it makes it very clear. There are two things that you're trying to do here. Okay. If I were to find, remember, x is 6. So why can't we take, if I was trying to find f of, remember, this is just a function, right? And we're going to replace the x values with whatever I put on the inside of the bracket. So x in this instance is 6. So 6 plus h. Let's see what happens when I do that. Well, that turns into 6 plus h, minus 2. I don't need the bracket either. Square rooted. Well, that is 4 plus h, square rooted. Right? And you guys know from grade 11 functions, when we first introduced function notation, if I were to plug in, f of x, whatever the value is, this is the y value. I want to know what the y value is of the function when I plug in 6. All right, well, we're going to go 6 minus 2 square rooted. Well, that's the square root of 4, which is equal to 2. Okay, you can use these two things now. If I were to replace these two, the x's in the question, with the 6, you now know, because you just found it, there's all this. Right? And you know f of 6 is 2. This makes the overall derivative or the first principles law a little bit easier to manage. Okay, and so what we're going to do is say, okay, let's just plug the stuff in. F prime of x is equal to the limit of h approaches 0 of root of 4 plus h minus 2 over h, right? So if we were to plug in h as 0 right now, we'd still have a problem if I was trying to evaluate that, right? Because I still have the 0 in the denominator. So we're going to have to figure something out, right? And this kind of gets to what you were doing this morning. Well, let's multiply by or rationalize, right? So two-term rationalization. So we're going to say, okay, well, let's multiply by 4 plus h, the square root of 4 plus h plus 2. And then, I have to put it over the same thing in order to get it to equal to 1 so that I haven't changed anything. Right? And so what we see is we're going to see, okay, well, and it's important, as I'm doing this, I'm recalling, make sure you are writing the limit all the way down until you get to your final answer. Okay? What we're going to see here, we're going to see that the square roots knock each other out, right? And we're going to say, okay, 4 plus h minus 4, though, because this times this. Okay, but that all has to be over. We've made the denominator a little bit uglier now, right? That's going to be over h multiplied by 4 plus h square rooted plus 2. Okay, but something nice happened in the numerator, right? 4 creates a 0 pair with the minus 4, right? And so we're left with f prime of x, the limit as h approaches 0. We get h over h times the square root of 4 plus h plus 2. I won't make that square root so big. Make that a little smaller. Now, look, h's cancel. What are we left with? Well, it looks like if I were to evaluate this by plugging in the h, I'm not going to get a 0 in the denominator, which is nice, right? So we can say, okay, and I suppose, sorry, one other thing, I have specifically said that I'm evaluating what the slope is, f prime of x, it's not x, it's f prime at 6. I'm specifically doing something, okay? And we get 1 over, we're just going to evaluate this now, 4 plus 0, square rooted, plus 2. So I get 1 over square root of 4 from here is going to be 2. 2 plus 2 is 4. So we know that the slope is going to be 1/4 at this value, x value 6. So in the event though, you know, I found that this makes my life easy, and I think it makes your life easier too. If we can kind of eliminate some of the variables and the x's and the number of x's floating around and things like that, that helps. Now, the problem with this method is I've solved for the slope at one specific value of x, 6 in this instance, right? Now, where this isn't helpful currently in its current state, it's great that we found this slope, but what if I wanted to ask you a question like above? And I wanted a whole bunch, right? Well, if we ask you, or if I ask you, the slope of the tangent line, like the equation of the line itself, this is not useful to you currently from the standpoint of you can't tell me you don't have an equation. Well, we can find the equation though, right? You guys know, this is grade 9, right? We know the equation of a line is y equals mx plus b. You have found, you know, if I were to write a list of unknowns and knowns here, you have found that m is 1/4, x is 6, and the y value we found to be 2. That looks like a 3 in there. 2. So, tell me what b is. Let's plug that stuff in there. So we're going to get 2 equals 1/4. And the reason why I'm showing you this is because we're going to see it come up in the next question. But this is the flaw with this. If you guys don't solve things algebraically with x's and h's, you don't get an algebraic expression that is useful to multiple points. Okay, and so I would say, where you can, I would say, try and do it algebraically. But this helped me a lot yesterday. When I was trying to do it algebraically, I was getting stumped, and keeping track of things, it just gets a little bit difficult, right? But if you can do it algebraically, do it algebraically. If it's asking you specifically for the equation of the tangent line, you're going to have to do it algebraically, or do what I'm doing currently right here and in solving for the overall equation. Okay, b. We solve for b. So I get 2 equals 6 over 4, right, plus b. Okay, if I were to bring this over, I'd have 2 minus, well, we could reduce that to be, actually, never mind, I'm going to leave it. 6 over 4 equals 2b. Solve for what b is. Okay, well, let's create a common denominator between these two things. We can multiply this by 2 over 2. We're going to get 4 over 2. Sorry, what am I doing? 4 over 4. So I'm going to get, sorry, let me just backtrack here. 8 over 4 minus 6 over 4 is a b. And so we're going to get 2 over 4. And so b is equal to 1/2. Okay, and now you can write out your equation. This would be your equation of the tangent line, right? We're going to say, okay, y equals, or f prime of x, I suppose would be a better way to write it, actually. F prime of x is equal to, you know the slope is 1/4 x plus 1/2. you now have an equation that will allow you to solve for the slope of any point along this curve that we started with originally. So both of these work. You know, if you find that this helps me a lot, I'm not great with the algebra side of things, and I get lost sometimes in the middle in the nitty-gritties of the work, which ultimately gives me the wrong equation, and I get the wrong slopes and things. So this is just the one thing, you know, I found worked for me yesterday doing some of these questions. You can always remember, you can always find the equation of the tangent if you know the slope and a particular point. Okay, so there is a workaround. Okay, you can pick. We saw above here, we solved this question completely algebraically. It sometimes requires a little bit more steps, you know. It comes down to the kind of question too, though, like how complicated the function is. Okay, so let's just have a look at question 3 here. Much the same. Okay. We want to find the point of contact on this curve. Okay, and so we're going to apply, again, I was talking about the tangent, so I'm going to need the equation of the tangent, right? And then I can use that to solve for the point. And then there's a little bit of a series as I'm reading this out loud and thinking, how am I going to attack this question? There's a series of events that need to occur here in order for you to arrive at the final answer, but it's all stuff that you guys have seen in the past. We're just throwing in this idea of first principles to get you there. Okay, so we have this function, f of x is equal to 3x squared plus 2. I would say, if we're talking about a tangent, I would say find the derivative, okay, or use first principles, solve for what the derivative is, okay? So we know the derivative f prime of x is going to be equal to, and you guys are going to become, this is a very laborious process of writing this out every time, but you know, you learn not to forget it this way. And the more of them you do, it's like anything, the more of them you do, the easier and easier it gets. The only way to make these more challenging is to change the functions that are here, right? They just make them a little bit uglier, and the overall math a little bit more tedious, right? Easy to make a mistake, that's all. Okay, so the problem with this is it doesn't tell me, you know, if I dissect what's actually given to me in this question. I'm given a function, no problem, okay, that we can do something with that. But let's identify what else is it given me. Well, it told me what the slope was, which is not an x value. It's not an x value. Okay, what it is, it told me what f prime of x is. So I know that I can go like this. If I were to come up with the equation, something blah, 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 x, whatever it turns out to be, that's going to equal -3. Because f prime of x is -3. It told me the slope already, okay? That's what's going on in my head. It's important for you to make the distinction between what it is that they're giving you in the question, because that's going to dictate the process and the thing that you're looking for at the very end. Okay, so I would say right off the top, I think we're going to solve this algebraically, which isn't a big deal. Okay, you just need to know. I would make it a habit of doing this. Let's figure out. I'm going to leave myself some space here because this is going to occupy a little bit of room. You know, let's figure out. I'm going to take my function f of x, and everywhere I see the x, I'm going to put an x plus h for this. Okay, so we're going to see 3x plus h squared plus 2. Right? I don't see any other x's, so that's fine. So let's we could even do the work right here, right? If you guys do the work separately on the right side, that might make the overall cleaning up over here when we actually do the try and find the derivative a little bit easier. Okay, I try and keep the stuff separate, right? So we're going to have 3x squared plus 2xh, sorry, plus 2xh plus h squared plus 2 at the end. Okay, so let's distribute the 3 in. We're going to get 3x squared plus 6xh plus 3h squared plus 2. All right, this is our function, f of x plus h. Now, the catch here is, though, I don't know an x value, and so I'm stuck with the fact that f of x is still 3x squared plus 2. Now, we have both pieces of information. Let's replace them appropriately in the first principles. F prime of x is equal to the limit as h approaches 0 of f of x plus h. Well, we learned that's what that is. So let's write that down. 3x squared plus 6xh plus 3h squared plus 2. Now, careful, minus 3x squared plus 2, all divided by h. Now, I did not do this when I was trying your questions yesterday, your homework questions. I was not doing these two things separately, okay? And I think this is probably the best way to do it. Just let's like simplify everything on the right, then throw it back in, okay? Now, we can distribute this negative into the brackets, right? And we should see some things start happening. Okay, you're going to get very bored of writing this limit of is equal to x plus 8, or x approaches 0. Okay, so we're going to say, okay, we're going to get 3x squared plus 6xh plus 3h squared plus 2 minus 3x squared minus 2. Remember, the negative has to go into both terms. This is where things could, that's the first point of error, I think, where things could start going wrong. Okay, and I think that's why it's helpful to write this out like this. Okay, don't forget, and then I did one question yesterday where I forgot to divide by h, and I got the wrong answer. Okay, now it looks like there's some nice things going on here, right? I see a positive 3x squared. That can create a 0 pair with the negative 3x squared. And it looks like a 2 can cancel or create a 0 pair with the negative 2. So what do we get? I get f prime of x is equal to the limit as h approaches 0, 3h squared plus 6xh, all divided by h. Wow, look at that. You know, if I were still to evaluate this, I'd have a 0 in the denominator. Not great. Okay, but there is something that I could do. I could remove a factor of h in the numerator. Okay, and again, maybe you don't do this in this step. You could even go cancel with a 2. Okay, if you guys like. For the purposes of the lesson and seeing this for the first time, I'm just going to so that people don't freak out. 3h plus 6x, you know, over h. Well, now the h's can cancel, and you're left with the limit. The limit as h approaches 0, 3h plus 6x. Well, what's the derivative? Well, the derivative is what happens when I replace h, or I evaluate when h approaches 0. So f prime of x, here's your equation. This is what's nice about doing it algebraically. You get the equation of the tangent out. Okay? And maybe my maybe doing this was my problem yesterday. Okay? If I write that stuff out and do all that simplification work on the separately from the equations that are trying to do it all in with the limit and all this stuff going on, right? That might be the source of my confusion yesterday. Okay. So if I evaluate, the 3h is going to disappear, and your derivative function is going to be 6x. Okay. Now, we also learned at the very beginning of this question, we know what the slope is. The slope is equal to -3. Well, this is the equation that represents what the slope is at any particular point. Well, it told us that the slope was -3. Okay. So we're going to say -3 has to equal 6x. So what's the slope? Well, or sorry, not even the slope. We know what the slope is. I said that 10 times. We can solve for what the x value is. Right? The x value of the point that they're actually asking about. Right? What's the x value? Well, we go -3 over 6 is equal to x, so x is equal to -1/2. Once you have that, you can go back to the original question, right? The original equation, because ultimately what we're interested in is the y value on the original equation f of x, not f prime of x, f of x. original. So take this x value of -2, plug it in. Not -2, -1/2. You're going to evaluate the original function at -1/2. So we're going to say 3 1/2 -1/2 squared plus 2. Is that right? Yeah. All right. So we're going to get 3 times 1/4 plus 2, which will be 3/4 plus 2. Create a common denominator here to actually get your final y value, right? So we're going to say, okay, 3/4 plus, we're going to multiply this by 4/4 to get the 4 in the denominator. So 8/4. So f at -1/2 is this. What's that mean? Well, the xy point for this question is going to be -1/2 and 11/4. That is the final answer. Okay. I'm happy to help. I actually kind of this I understand where you guys are coming from, learning this for the first time, or maybe you guys are taking this for a second time. I don't know. I remember looking at this in the first place in grade 12 and just being absolutely lost. Okay, so I'm happy to help you guys because I feel pretty confident being able to do questions now. I'm happy to help you guys. Okay, and I've done enough questions now. I think that there's no hiccups. Okay, I actually kind of like this now. It's kind of fun. I've tried to give you the steps, and the nice thing about me figuring this out is I think recently, right? Figuring out recently is that you guys can follow the steps that have worked for me, and knowing that I've struggled with this in the past as well. Okay, so this is just some tips that I found have worked for me in the last couple of days in figuring out these questions, right? So if you guys follow this stuff, you know, hopefully that that alleviates some of the stress around doing this for the very first time or coming back to it. Okay, so that's this afternoon's lesson. There are some questions as well posted. What I will try and do is keep ahead of you guys, and if at all possible, I'll post solutions to homework questions if I have them, if I have time. I'm not going to promise I do this every day, but I'll let you guys have a crack at them, and then I'll post them maybe say tomorrow or something like that, so you guys can have a look at them. Okay, so have a good look at the homework questions, and then let me know if you have any questions as well. Okay, we'll see you guys tomorrow.